Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS in Land Science. Before we get started with the webinar today, I have just a couple of administrative items to cover. Since we're trying to limit our time to an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we do not address your question, we'll make an effort to follow up with you after the webinar. We're recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's webinar will focus on best practices for safe and effective in-situ remediation. With that, I'd like to introduce our presenter for today. We are pleased to have with us Mr. Jack Sheldon, Senior Remediation Specialist at Antea Group. Mr. Sheldon is a remediation expert with over 35 years of industry experience. He has specialized in the field application of various types of bioremediation and chemical oxidation and reduction systems, with personal involvement in 22 first-type remediation projects in their respective states. He has completed remediation projects in all 50 states and several locations abroad. All right, that concludes our introduction, so now I will hand things over to Jack Sheldon to get us started.
Dane, thank you so much for that kind introduction, and thank you to REGENESIS today for hosting this webinar. Also, thank you to all of you that have taken the time to join out there. I hope that when you leave today, you'll feel like your time was worthwhile and that you picked up some interesting information. So in the past, I've had the opportunity to present other webinars for REGENESIS. And a couple years ago, I presented on how to monitor sites in which REGENESIS products are utilized. What do the monitoring programs look like, and how do you interpret results from those? Last year, I was able to present a webinar on a case study that involved multiple REGENESIS products and REGENESIS field services, and how combined remedies can be effective in leading you to a solution on a site. Well, today I'm going to present something that's radically different, and I hope that this works for all of you. It's a thought process webinar, and it's a webinar that's going to focus heavily on safety. And I can tell you from experience that thinking and safety jive well with your interaction with REGENESIS. I've had the pleasure of working with REGENESIS for a couple of decades now, over a couple decades, and we've had a tremendous amount of collaboration, noodling on some pretty difficult problems, solving those problems, and working safely while doing that. So again, today's webinar is going to focus heavily on project thinking and on safety. So the objectives today, I want you to leave here and be able to think about key project issues. The more thinking you do, the more planning you do, the better your project is going to be ultimately. I also want you to look at the tool I'm going to introduce to you in just a moment, and use it as a tool to get your project team to buy in to the overall path forward on a project. There's nothing like having a project team that works in concert with one another. And that's not only internal folks, that's also the client, the end user, it's also the subcontractor, and that can very well be REGENESIS and REGENESIS Remediation Services in a number of applications. I want you to leave here and think that you have ways now to improve project performance and make safety paramount in all your projects. And then lastly, by using a project checklist, it's a great way to support interaction with REGENESIS and its field service arm, RRS. So the checklist. So any remediation vendor out there that has a product likely has some type of a site evaluation form that you can fill out. Often those are electronic, they're online. You can fill in your information. That provides the vendor enough information to help you make a selection of a technology on a project, and then help you work through a design to get something in the field. Well, that's great, and that serves the beginning of the process very, very well. But I can test that maybe some more information is needed. And so we at Antea Group, we have built a system that allows us to ask some very distinct, very critical technical questions and very distinct and critical health and safety questions. We've done this for mechanical systems, we've done it for excavation, but we've also done it for all of our in-situ systems. And I can tell you, we do an awful lot of chemical oxidation projects, ISCO, year in and year out. And this form, this checklist, has been such a critical tool in that process because it shaped our thinking. It's allowed us to ask tough questions right from the start, and it's allowed us to see our project succeed as a result of having good information. So if you look at the circle to the upper right here where my cursor is pointing, you will see that things are divided up into select, design, and execute. That's select technologies, design a system in the field, and execute or implement, and then follow up that implementation with monitoring out in the field of an in-situ system. You'll also notice with the small circle here in the middle that we have categories of staff listed, including a reviewer. What this is in our checklist is a little system that we use so that each of these individuals assigned to a specific project can sign off and they buy in to a particular response in a given category. And then to the right here in the larger circle, we have various line items that are listed through the select process, through the design process, and through the execute process that point to pieces of information, that ask questions. I don't show it here on the slide, but if we were to extend this, this form out horizontally, you would see that we would have sections in there for each of those project team members to incorporate pieces of information. So we have a running dialogue and a planning tool. Ultimately, the person assigned to review the project and all the technical accuracies and the safety components can look at that dialogue and be assured that the project team is on board and that they've truly flushed out the information that's critical. So just looking at some of them there, remedial objectives have been clearly defined, right? That's the first line item. Isn't that so important when you're doing an in-situ remediation project? Have we identified the barriers to closure? What are those going to be on any given site? Dropping down here, do we really understand what all of our constituents of concern are? Do we know what our VOCs, our SVOCs, our TPH, our chlorinated solvents, what do they all look like in the process? You know, what do we know about the metals that are present on our site? Do we have them? Do we just have background metals? So all that information is pertinent in the process. And then in looking at the last line item there, how about significant NAPL present on a site or a history of NAPL? Wouldn't that be important in terms of mass contribution? So these are things that are part of the process. And so what I'm going to do now is I'm going to jump into an actual site, one that we at Antea Group did with REGENESIS. And this is a site in Seal Beach, California. It was an in-situ chemical oxidation bioremediation project, so combined remedies used on the site. It's a site that achieved closure last year, one of 7, where we used different combinations of REGENESIS chemicals, and we're able to achieve closure on those sites in Southern California. So when put in place, the process can really work. So what do we glean from those simple bullet items that are there? First of all, we know we've got a service station, so that triggers some thoughts in our minds that, you know, what kinds of things go on at a service station? You know, there's car maintenance, there's cars that are leaking oil that park in parking spots, there's gasoline dispensing, there may be assorted other maintenance outside of individual garage bays that leak fluids onto the ground. There's numerous activities. There's vehicular traffic, and that can certainly be a big component. We know we've got benzene, MTBE, TBA, so we know what our constituents are that we're dealing with. We know something about them. We know that we can biodegrade those under certain scenarios. We know that we can chemically oxidize them under certain scenarios. We know we have groundwater impacts if you look at the first bullet, But we also know that we have remaining saturated sorbed impacts, and that can be a critical factor because that's going to contribute to your dissolve phase going forward. Looking at the second bullet, we know we have silts, sands, clays, might imply some sort of a layered type scenario on the site. We know we've got fairly great heterogeneity that's present, so we're going to have to contend with that as part of the design of our process. And we also know that we have limited plume movement. So what does that tell us? We have perhaps some sort of a bathtub type scenario where our plume is relatively stationary and migration is not going to be one of the key issues that we're going to have to deal with. We also look at the concentrations there, benzene, MTB, TBA, total petroleum hydrocarbon as gasoline, and we see what some of those general concentrations are. And we know that those concentrations are not particularly high and that they're very, very manageable concentrations, and potentially with both chemical oxidation and bioremediation, we can get a successful result. We also have some field data that tells us that we've got on average about 1 milligram per liter of dissolved oxygen. And that's very important as well, because that tells us that we can probably tip that up a bit more and create a more robust aerobic condition on the site. If it were much, much lower than that, then maybe we'd give some consideration to an alternate approach as opposed to an aerobic bioremediation. So 5, 6 simple bullets here, and already we have a wealth of information. But the bottom line is, in order to really round out our checklist, we need more. And then we get to something like this. I chose this site figure for a reason. It's messy, it's crazy, it's chaotic, and it's exactly what you and I deal with on each and every site. Well, unless you're working in a vacant lot. Look at all the things that are occurring out on this site. This is the gas station site, right? And it's, it indicates where our canopy is present, our dispenser islands. Down here, we have an underground storage tank, which undoubtedly has some piping that comes over and feeds the dispenser islands. And look at this, we have some remedial system piping here as well. So another conduit in which things can flow into. We've got a series of lines, blue, red, yellow. All of these are subsurface utilities, things that are going to make an in-situ approach challenging. Well, and then to the right of the screen here, we have a driveway, we have a sidewalk, and that creates its own set of challenges. That means there's going to be traffic that's going to be moving through the area that we deal with, that we treat. And then up here to the top of the screen, we have a planter, and we have another planter, and we have a gas meter. So that tips us off that we have gas coming into the site. Planters are very interesting too, because they can oftentimes contribute quite a bit of nitrate into your site, which is very interesting. And there's live vegetation there, and that's another consideration when working on a site like this. And all the dots that you see there are different rounds of injection that's taken place. I wanted you to see that beyond just the infrastructure, beyond just the logistics of the site, because that shows you, all that has to be worked around when an in-situ system goes into place. You'll notice in some areas of the site, like up here in the upper right corner, the points are more spread out, and we've got some challenges. They're more spread out here in the middle, where we've got quite a bit of infrastructure, and yet they're closer in density in areas of the site where we don't have as much. So all those things are factors in terms of creating the proper environments in the subsurface in which to create treatment. Every site has closure criteria. I've just listed a series of them for a site here. Yours may be altogether different. You may be in a site where your target benzene you may be in a state, I should say, where your target benzene concentration is 3 micrograms per liter. You might be in a state where it's 5. You might have a risk-based scenario where your target benzene concentration is 250 micrograms per liter. So your scenario for closure is going to be different site to site. You may have environmental covenants in play. You may have all sorts of other issues, such as the ones listed here, that may be critical factors as you now get into the select, design, and execute for your remediation system. So let's dive into selecting technology. That's the first of our 3 critical areas in our checklist. Now, I mentioned before, we were dealing with a service station site. So the first thing that should trigger is, what type of site am I working on? What are the typical sources of impact on that site? What do I normally see on a gas station site? Now, those of you out there, we have a broad array of people that are online today. You might work on chlorinated sites exclusively, so your thinking is going to shift to a manufacturing site, perhaps a site where they're making a particular type of product, or they're degreasing some sort of part. And so your sources are going to be different than what you would see on a gas station site. But this is probably your first critical piece of information, is to understand something about the type of site you're working on. You might be working on a chrome plating facility, and you might ask yourself the question, well, what kind of chrome plating do they do? Do they use hexavalent chromium, or do they use trivalent chromium? And then what happens to those when they get in the subsurface? But again, the point here being that at this particular stage, as you're selecting technology, this is the time for you to generally get up to speed on the type of site that you're planning on remediating. Well, on the heels of that, you're going to go through a series of historical searches, and you're going to go through a series of data collection, and you're going to build yourself a robust site conceptual model, conceptual site model, call it what you will. And a conceptual site model is not 3 sentences that you write on a page. A conceptual site model is a thorough understanding of the goings on the site. What creates my source of contamination? Where does it go when it enters the subsurface? What is at risk? What sort of factors are acting upon those chemical constituents when they get into the subsurface? And this kind of goes around in a circle for a reason, because once you gather that information, you build that conceptual site model. That certainly dictates your conceptual site model and what you're going to go forward with as your understanding of the site. The more you skimp on information, the less complete this is going to be. And I've had many a person say that, a conceptual site model is way more than pages of text that describe certain scenarios. A conceptual site model has to be so good that you can define the complexity in a simple cartoon. So keep that in mind. A good conceptual site model is such that you can define all the complexities in a simple picture, simple cartoon. So as you're going out and you're gathering information, I strongly encourage you, as a best practice, collect good quality field parameters. I beat this horse dead in many a webinar and many a presentation, but there's something to be said for somebody that can go out to a site with a probe or with a flow-through cell and can gather good quality field parameters. pH that makes sense, dissolved oxygen that's not 37.6 milligrams per liter at every well, but a real number that you can actually come back and interpret when you get it back to your office. So the practice of collecting good quality field data is so important. They seem like simple parameters, but conductivity, pH, temperature, oxidation reduction potential, dissolved oxygen, when you have those good quality parameters, now you can start to make heads or tails of what sort of conditions exist at your site. It's going to aid your technology selection. You want to collect geochem data, right? A lot of sites I've seen historically, you go out, you get your contaminant data, well, maybe you get your field parameters, but you say, well, I don't want to spend money necessarily on those other things. Well, I think you're missing the boat. You're missing out on some incredible information that also can shape your thinking on the type of remedial product that you ultimately select for your site. You want to know where your site lies on the redox ladder. What kinds of microbes might be in play there, and they always are in play. Sometimes they're doing good things, and sometimes they're not doing good things, and I think you want to know that as you go forward. You also need to know if one or more parameters is out of whack. If something looks unusually high or unusually low, based on the scenario. All these things are important. They contribute to your conceptual site model, and they're also important after the fact. Should you put a remediation system in place and things don't go according to plan, when you've got a complete data set and you have field parameters, geochem, contaminants, all those things together, now you can start to make heads or tails in your troubleshooting process. So collect geochem data. I've also beat this one to death on many a webinar and presentation, but maybe it's because I'm a microbiologist and this is my passion, but I think you're also missing the boat if you don't collect some sort of microbial data. We have so many robust tools that we can use these days to get better data. We have different types of sampling devices, as you see there, different ways to collect those samples. And then in the box there, with the bullet items, we have different types of analysis that give us different levels of information. Do I just want to know some general things about my microbial population and the numbers of microbes that exist? Or do I want to get deeper into it? Do I really want to understand the degradation mechanisms that are in play at my site? And do I really want to prove that? Do I need to go to a level that I need compound-specific isotope analysis or stable isotope probing to actually show someone that I've got degradation occurring at the site? And then there's other levels that you can drop to. Again, all these analyses are available to you at different price ranges and will be very helpful to you as you make your technology selection, build out your conceptual site model. And then there's that wide array of investigation tools and other test methodologies that exist out there. Many of you use CPT on your sites to get information on lithology, and then there's UVOST and MIP, the hydraulic profiling tool, water injection tests. All these things can be valuable. It's incredible how much information you can get out of a single day's worth of probing at a site. And you can put in a lot of holes in a single day and collect a lot of data. And of course, as mentioned earlier, field parameters, geochem, treatability studies I'll talk about in a second, but there's other things you can use to gather information on a site to make your technology selection. It can be tracer studies, grain size analysis, slug testing, pumping tests, the list goes on, soil cores, if you're more old school like I am. But there's lots of things that can be availed to you that can help this selection process along. And by all means, don't forget to use Google Earth. Don't forget that very basic and simple tool as a great way to look at your site. Even if you haven't had opportunity to visit it yet, it's a great way to visualize it, look at the surroundings to the site, and gather information that way. Then lastly, as part of your selection process, another key factor is the chemistry itself, right? Perhaps you're someone on this call that's used every single REGENESIS product. Maybe you're someone that's never used a REGENESIS product. So just a very, very brief reminder here. REGENOX is a moderate to strong oxidant that you can use on sites. It's infrastructure safe. It's sodium percarbonate based, leaves behind some residual oxygen, which can be an added bonus. It gives you an opportunity to bioremediate, biopolish on the tail end of your oxidation. We've grown accustomed to using REGENOX Part A as a very nifty little desorption mechanism on sites. It has some very interesting surfactancy properties due to pH and other components of the chemistry, and can make for a nice little desorption chemistry. Persulfox being an all-in-one product that we use, a strong oxidant, something where you can add it. It's self-activating. That's a real big plus to those of us that have to add chemicals in the field. Always easier to add one chemical as opposed to multiple chemicals and trying to marry them up. So a little bit on those chemistries. And then ORC Advanced, oxygen release compound, a means by which to get oxygen in the subsurface, build a more robust and more uniform aerobic condition. And When you put oxygen in the ground, you first get increased numbers of microbes. That's called growth. The densities of them increase, and then as a result, the ability to degrade more and more mass, the rate at which to degrade that mass. That's the beauty of adding oxygen to a site. And then lastly, certain sites plume stop. Maybe the chemistry that you're looking for, liquid activated carbon, a means by which to retard the plume, to create a sorption site by which contaminants will stick and become embedded within that matrix, and then subsequently able to be biodegraded as that moves to the interface of the carbon particles. And oftentimes we find plume stop used in barrier type configurations. So all those chemistries are possible. I haven't even addressed the chlorinated side of things today. I started with a petroleum site, so I'll kind of stick to that theme as we go forward. But certainly there are lots and lots of chemistries that are available on the chlorinated side as well. All right, so we've moved our way through selection. So I think I made the point, you need robust data collection in order to make selection of the appropriate remediation chemistry and products that you're going to go forward with. So now you're at that very critical stage where you have to design something that's going to go into your site. It's going to go into the field. So what are some things you need to be thinking about? Okay, well, first of all, in the case of REGENESIS and others that are out there that sell remediation products, there's often vendor design software, and you can work collaboratively with your vendor to go back and forth and work through the numbers, work through the volumes of injectate you're going to need at a given site, work through the number of points that you're going to have out on that site, work through the best way to apply a chemistry to the subsurface, be it wells or galleries or temporary points or direct push points, or maybe soil blending might be the best way to get the chemistry in place. Don't skimp on advice from other subcontractors as well. Your driller will oftentimes have a tremendous number of insights because they know the local geography. They drilled in that terrain for many, many years. They have in-depth knowledge of particular tooling, and their insights can be incredibly valuable in addition to just the advice you get from your remediation product vendor. Revisit your mass calcs. Probably the single greatest way that we as consultants miss the mark on sites is because we have a poor understanding of the contaminant mass that exists. You really need to look at that issue critically. You need to run the numbers. You need to have enough sampling completed that you can get a good mass calculation. What's in the soil, what's in the water, maybe there's thin layers of product that exist or seams of product. All these things contribute, and so the more knowledge you have in that area, the better your design is going to be. Look at photos, visit the site, take a good hard walk around the site and look at all the things that appear. And then finally, when you're ready to lay out a design for a remediation system on paper, start thinking about how am I going to apply this? What's going to be my sequence of application? Am I going to start on the outside of my plume and work my way in to the more heavily impacted area? Do I have to work in an area of the site first because there may be some sort of property transfer that's going to occur and I have no choice but to have to start there? Also, maybe I'm in a scenario where my site has certain hours of operation. I have to work around that. So that's going to dictate how I apply material in the subsurface. Also, what kind of effects do I expect from groundwater advection? Once the material goes in, how do I expect it to distribute in the subsurface? Do I expect it to get hung up and take a long time to show up in my wells? Or do I really expect a rapid result? That's something that I can see very, very quickly. How about the vertical component? Probably more chemistry, more remediation product is wasted when people don't understand the vertical component of an injection. Way too much product gets put into layers or vertical horizons that don't need it. Put it in where, in fact, the contaminant mass lies, or where there is contact with a matrix where Matrix diffusion, back diffusion may be critical. Those are important points. And then think about the obstructions in the subsurface. The photo on the bottom right of the slide shows you in the white some areas that were envisioned for placement of some injection locations, and the red shows some infrastructure that's present in the subsurface that may dictate the movement of those injection points to another location. So there's a certain amount of standoff that has to take place in the field, whether that's 5 feet, whether that's 10 feet, maybe that's more in some cases, and that's a critical component of your design. Oh, how about treatability testing? Right. Oxidant demand testing can be a very important number to have as you're going into an ISCO application. Yeah, you can use default values on sites. I mean, that's commonly done, but I like to collect real data. I like to pull a sample from an unimpacted area of the site, send it to the lab, look what my natural oxidant demand looks like, and then add in my contaminant mass on top of that and figure out my, my loading of oxidant that's needed. Or maybe your site needs some sort of jar test or batch test where you're looking for just sort of a proof of concept that, yeah, this chemistry is really going to work with the soil and with the groundwater and its constituents at my particular site. And then to the right here on the slide, maybe a column test is in order. Maybe you want to look at the flow characteristics through a cell. Maybe you want to set up a column of plume stop and look at absorption isotherm and just see how benzene sorbs or how TCE sorbs or how chlorobenzene sorbs. Any of those things are achievable through a laboratory test. And I would say that laboratory testing, treatability testing should not be forgotten. I think 25 years ago, we did bench tests routinely, pretty much every project. Now we do it perhaps a little more selectively, but we do it for a purpose. We can get really good information out of it before we actually go to the field. Earlier, those fancy tools that you used for a high resolution characterization produce graphics that look like this, that can really clue you in on the vertical components that you need to pay attention to. Your sand zones, your clay zones. Again, the stratigraphy is so important. Understanding where mass is moving at a site, understanding where diffusion may be an issue, understanding where you may have a confining layer. All those things are critical as part of your design, and you get that through the high resolution characterization and graphics that come out that look like this. And then plan view of our data also. Here's some membrane interface probe data that gives us a sense on a site plan layout of some of the target areas, the real footprint that we have to pay attention to, the area that we have to focus in on and treat. So I think it's important in the design process that you have a lot of different views, be it three-dimensional, be it stratigraphy, be it site plan views like this. I think all of it is good, and all of it gives you a spatial representation and a way to look at the site that's just going to help you make the design better. Lastly, we'll talk about the execution phase of a project, and this is the critical. This is where the rubber meets the road, right, folks? It's where you've done all your homework up front to make a technology selection or selection of technologies. And then you've gone through all that trouble of spending time on the details to get the right design in place. Well, now you got to go out in the field and you have to make it work. So what are some of the questions that a checklist might have that you need to pay attention to? So let's start with this. How about, is my injection subcontractor up to speed on the project? I mean, have they been in on the process, or are you going to surprise them with the design? Are you going to surprise them with what's going to happen out in the field? I like to hire contractors that know the area, that have injected the chemistry before, that know what to expect. I think that's very critical. I like to hire REGENESIS to inject their own products for just that reason. Who should know their products better than they do? Makes sense to me. How's the site access? Do you have one entrance in, one entrance out? What about accessing a neighboring property? Are the proper agreements in place that give you access? What's the procedure to getting onto that neighbor's property? All those things are really critical. That's a really hard thing to find out after the fact when you're out in the field with a bunch of people on site ready to work and that issue has not been clarified. How about permits? Injection permits, are they in your respective state? Are they issued by the state itself? Are they issued by the health department? Are they issued by EPA? What about discharge permits? How about air permits? How about those other unusual permits out there that can sneak up on you? How about things like in Northern California, I've often experienced a borehole permit where your borehole is actually inspected, and the way that you close that borehole is inspected by a county inspector. And that's something that exists there that I don't see in too many other places. How about in the city of Chicago, when I want to cross a city sidewalk with a heavy piece of equipment, I have to get a sidewalk permit in order to do that. Those are those things that you want to find out at this execution stage before you're on site. How about your health and safety plan? Did you just pull one off your company's website and plug it in and say, well, this is good, without really thinking about the specific issues on the site, really thinking about the chemicals that are there, the types of chemistry that you're now going to put in the ground? I really think you got to take that time and develop that specificity. And you have to get a health and safety plan from your subcontractor as well, or at least a job safety analysis, a JSA, so that you have sort of their plan, their thinking, their way of doing things, their way of managing safety. All those things are important. Ask yourself, have I visited the site, or have I at least looked at a photo? Have I gone to Google Earth and looked and see what my site looks like? And am I prepared to take more photos to document other things that occur on site? I think picture says 1,000 words, right? And I think the more site photos you have, particularly at this execution stage, the more important they become down the road. Other questions you might ask yourself: does my site have ground cover or not? So what does that mean? Will your site be susceptible to infiltration from rainwater or runoff from some adjacent property? If it is covered, what's it covered with? Asphalt, concrete, grass, what exists out there? What's the integrity of that cover? Do you have a major sinkhole in the middle of your site? Do you have an asphalt that's 10 years old that has an incredible number of cracks in it? All those things are critical pieces of information. And how about infrastructure? Boy, it's awful costly if you hit a fiber optic line. So you need to know certainly what's in the subsurface at your site. How are you going to find that out? You're going to look at as-built drawings. You're going to look at just facility drawings that exist. You're going to work with utility locators. You're going to probably do some air knifing. You're going to do perhaps some hand clearing. And you're going to perhaps use ground penetrating radar to identify structure. Maybe several or all of those in combination. What does your site traffic look like? People and vehicles. If you're working at a fast food restaurant and you're working in the middle of the day, it's the lunch hour, and there's scores of people that are coming by, where you're going to want to have keen attention to your activities and the number of people that are around you under that scenario. And then, of course, you're going to have to think about vehicles. On my gas station site I talked about earlier, that meant cars. That also meant the fuel tanker that comes in. Your site, it might be delivery trucks or other types of tractor trailers that come in. It could be forklifts that buzz back and forth. It could be some light rail, short line rail that comes in that drops off supplies once a day. All those things are critical pieces of information that may affect how you execute on the site. And then how about storm sewers? It's a really hard lesson to learn when you suddenly have material you're injecting in the ground that emerges to the surface, flows down slope, and winds up in your storm sewer and then goes off to who knows where. And You know, what happens if your regulator's on site that day? That's probably not a surprise anybody wants. So knowing that that storm sewer exists and how that's going to be managed in the event that there is fluid that surfaces, that daylights, that's going to find its way to that sewer. And then how about vegetation? How about setting a proper expectation right from the start on a project? If there are trees and there are bushes or there are plantings in very close proximity to your treatment area, and there is a decent likelihood that you will daylight injectate, then you'll have to set that expectation that there will be some loss of that vegetation. I've seen miraculous scenarios where fluid has daylighted in a planter or to an exotic tree, and it's miraculously survived. But I would say that that's the exception rather than the rule. So I think you have to set that expectation in your execution that if there is sensitive vegetation in proximity to your treatment area, it's probably not going to survive. And what else do you notice about adjacent properties? That's a critical piece of information as well. As you get into injection specifics, you certainly want to understand your number of injection points. How many injection events are you going to have on a site? If it's a bioremediation site, you know, maybe it's probably 2 or 3. A chemical oxidation site, probably 2 or 3 or 4. Depends on your site and the amount of mass that's present. You're certainly going to want to understand your injection interval. Again, you want to use chemical in an optimal way as opposed to inefficiently. You're going to want to understand your technique, especially if you're direct pushing. Is bottom up or top down your better way to go? And that's determined by consultation with your own experience, REGENESIS, your direct push contractor. All those people can weigh in and make that decision. And then your volume you'll inject. Do you want to have more points, less volume? Do you want less points, more volume? And there's some critical decisions that have to be made there. And then, of course, spacing. You know, are you going to get crazy and go 50 feet apart with points? I think not. Under most scenarios, am I going to be more like 8 to 10 feet apart, 15 feet apart? Well, that's seemingly more like it on most sites. And then, of course, at this juncture, again, you're going to want to try to anticipate the daylighting potential, right? Because daylighted injectate can come up at all sorts of locations and quite a distance from where you're injecting. So that's something critical to pay attention to. And when you're all done injecting, whether it's ORCA or it's Regenox or it's Persulfox or it's Plume Stop, you're going to want an injection report. And if it's RRS, I know you'll get one. If it's several other contractors that exist out there, they provide them. Some don't, and I would certainly ask them to provide it to you because you want to know what was the pressures that were needed for breakthrough and for sustained injection. How about the gallons per minute? How about the flow rates? How about the intervals that you're looking at? How about any particular notes that might cite an unusual circumstance that was experienced during the injection process? All right, I'm in the home stretch here. Hopefully you're all with me yet. And I said that I wanted to address safety here, and this is critical. This octagon is a great way to think of safety as you go forward on an in-situ remediation project. We're going to skip biological and radiation today because they're things that the vast number of you don't deal with on a regular basis, if ever. But chemical, motion, pressure, heat and cold, gravity, electrical. I just want to point out certain things that you may want to pay attention to under each of those categories that are going to improve your project and improve your ability to work safe. From a chemical consideration, whenever you've got chemistry out there that can cause burns, that can affect your eyes, that can cause issues with inhalation, you want to be especially cognizant as to what that comes in contact with. Read the safety data sheet. We all have them on sites. We all have them when we have our tailgate safety meetings. How about we read them And start off by respecting the chemical, respect the chemistry, because even the most benign thing can create a problem if it's disrespected. You can make a lovely vegetable oil or emulsion product type solution and have that surface all over your site and have a serious slip trip hazard. So even things as benign as that can cause a problem. So certainly when you're working with things like oxidizers, you have to respect the chemistry. Transportation, ISCO chemicals are regulated under the DOT. They have to be properly placarded. I'm sure most of you are not in the business of hauling chemicals, but some of you are. And certainly the chemicals have to be hauled by someone that has the proper hazmat training, that understands the labeling and marking associated with those chemicals. We're not talking about hydrogen peroxide today, but should that chemistry be on your site, that ups the ante quite a bit, because then you have oxidizer and secondary hazard corrosive that can be really, really critical. So, how you transport chemistry to your site is something you need to be aware of. If REGENESIS is doing it for you, hey, all the better. It shows up on your site, but you may have other means by which that chemical is being shipped to your site. Handling an application. How do you get hurt on a site? You get hurt when the wind blows and reactive dry chemistry winds up in your face, or winds up in your hands, or you breathe it in. You get hurt when something splashes on you. Why? Because you let your guard down for a minute and you dropped your safety glasses, and the next thing you know, some solution is in your eyes, it's on your face, got on your hands, and then you touched your face. So dry goods and splashing are two ways in which you get hurt on sites. So start off with at least minimal PPE, a Tyvek. Maybe you've got to graduate to something more hardy in terms of coveralls, protective boots, gloves. Usually the little latex gloves are not good, not necessarily your best choice. Goggles and safety glasses, if you're really going to be that person doing the mixing or hovering over a mixing tank for remediation product that's being mixed, you're going to want a face shield on. It's not sufficient to just have safety glasses and goggles. And probably one of the biggest things that's omitted at a site, and it's OSHA mandated, OSHA required, you need to have an eye wash station, preferably one that has a shower with it. Little squirt bottles of water or the garden hose running from the service station is not sufficient. You may have used that in the past, and that may have been, just gone along swimmingly for you, but really you need to have an eye wash station. And I know if you work with RRS, that type of equipment will be present on the site. And then you need the particular respiratory protection should you get into dry goods and scenarios where that may dust. Storage, I will call out a couple things here. One of the biggest omissions on sites where we do in-situ remediation, particularly when we have oxidizers present, is a failure to notify the local fire department. You think that's not a big deal? Well, it can be. There are places around the country where the fire department actually issues a permit for your ability to store an oxidant on site. It's not too common, but it does exist. Many fire departments will just simply thank you that you've notified them you have an oxidizer on site. And other fire departments will really want to see what your plan is for storing an oxidizer, for what sort of period of time will it be stored. And they're going to want to know what precautions you're going to take should that oxidizer spill. In the most extreme cases, the fire department's going to insist that you store your oxidizer chemicals, things like Persulfox, Regenox, and they have you store them in a Conex box or put them behind a fence and tarp them. So all those things are possibilities. So don't forget about the local fire department. And then, if you do have to store chemicals on site, make sure it's in a proper container. Bad things happen if you take Persulfox and you put it into a steel drum. and you let it sit there in the baking sun. You don't want to see that result. So you want to use a poly drum. So you want to take those types of things into consideration. Spills and releases, we touched on that earlier. Daylighting or surfacing is a fact of life on every in-situ remediation site. It was a fact of life on the Seal Beach site that I talked about at the beginning of this webinar, and it's probably a fact of life on your site. So whatever you can do in terms of booms and other sorbents, non-organic sorbents that can protect the flow of that material from finding its way to some low spot or to a drain, that's very important. You can put drain covers down. There's a variety of things you can do to manage that daylighting, especially paying attention to your injection and not getting crazy because it's 4 o'clock on a Friday and you want to get to the bar early. You don't want to up the rate of injection just because you feel like you need to speed it up. Let the injection run its course and let pressure and flow be at a manageable rate. We talked about disposal and in a proper drum. I know in a lot of sites, if you're injecting a large enough volume of fluid, you can have a vac truck on hand that can suck up any kind of spills on smaller applications, perhaps a shop vac scenario where you can suck up that fluid before it gets too far. Under certain scenarios, you may be able to put that back in the mix tank and reuse it. I don't recommend you try to neutralize anything on site. If you do happen to have material that has to be disposed of, I think you just get it secured and get it shipped off properly, unless you have somebody that's highly trained in that type of management and that the waste is well characterized. And I think some of this can be averted in the beginning by simply calculating how much you're going to need and how much throughput you can do within a single day. Not going crazy about how many batches of injectate that you mix. Pressure, we all know about that. You may want to set a guideline for your sites, maybe a sustained pressure no more than 100 PSI. Or maybe you want it higher than that. That may be a company by company specific. You want to test your piping and your delivery systems that are injecting remediation chemicals and make sure they're operating at 150% of their operating pressure. You want to check for leaks. You want to use whip checks to hold hoses down. When fluid's passing through a hose, that hose moves around. Motion. We got lots of things in play at sites. We've got people moving, we've got hoses moving, we've got cords moving, we've got open holes that a person could step in. Maybe we're taking covers off of wells. We've got vehicles that are moving around. So from a motion standpoint, those are things you need to pay attention to. And we have some examples there in the slide photos. Gravity, a lot of sites we don't pressure inject, but we gravity feed. That may entail having tanks lifted up at a particular level to generate more head. That in and of itself can create some risk. We also want to be sure, when we're lifting around dry bags or totes, that we're doing that in a proper manner. And again, paying attention to slips and trips and things as we're gravity feeding on a site. Heat, we certainly all worked on hot days, and we know that the heat stress can manifest itself, so we want to be cognizant to that, perhaps even adjust our PPE under certain circumstances. We want to be cognizant of things that have exhaust or things that get hot during the course of an injection event, engines, compressors, and under certain scenarios, the ISCO chemistry itself. You want to be cognizant, potentially of a reaction, particularly in warmer weather, that could up the temperature of the solution that you're working with. If you work within proper ratios that have been specified most of the time, that's not going to become an issue, but it can be. And then lastly, electrical. There's certainly, we have various devices that we have on site. that run by electricity, so we need to be cognizant of those, perhaps adopt a lockout tagout procedure. Also, be cognizant of underground electrical. That's certainly one of the ones you want to avoid at all costs. Keeping a sense of everything that's energized. And then just to wrap up here, I wanted to make a couple comments on the monitoring that exists on a site. Field monitor during the course of injection. There's nothing worse than doing an injection event and not having the capacity to monitor it. I think you want to be prepared for that going in, and you want to collect all the field data that you can and all the observations that you can while you're monitoring. And then set a period of time when you're going to collect samples. Probably no sooner than 14 days, but some sites 14 days is a good time to get out and actually go out and collect the sample on site, or 30 days or 45 to 60 days. Those are ideal time frames to see chemistry in action. And if you're not monitoring an injection soon enough after the injection event, you're going to miss something. And then lastly, just some additional thoughts on post-injection monitoring. Most of your action takes place in the first 2 months post-injection. Certainly true for oxidants, can be very, very critical for bioremediation agents. That's a very sweet spot of which to see progress and maybe get a sense of how much progress you're going to make down the road. And then my last point, if in fact you do chemical oxidation on a site, keep in mind that the chemical oxidant may have found its way in a very connected manner to your monitoring well. And when you go out to sample at some specific period, the pH of that well may be very acidic or very alkaline. So check that before you even pull your sample, and be prepared to have the proper PPE in place. We're ready to wrap up. I think we'll have a little time for questions. I will certainly get back to you with any other answers, but I guess the message today is as you employ a project checklist on sites to better improve performance and safety, make sure data collection is a part of it. Make sure you're ultra prepared. Make sure you're asking yourself and your project team the hard questions, paying attention to the details, and make sure when you get out on site, you have a keen sense of awareness. You're really looking at the things around you. Be open-minded to various options, and that will yield better results for you and help you save money. So with that, I'll take questions in whatever time we have. And I want to acknowledge just my colleagues at Antea Group that were instrumental in contributing to the aspects of this presentation. Have fun developing your checklist, and hope it leads to safe and successful projects. Dane, back to you.
All right, great. Thank you so much, Jack. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion. We do have a couple minutes for some questions. Before we do this, just a couple reminders. First, you'll receive a follow-up email with a brief survey. We really do appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions. If we're not able to get to your question today, we'll make an effort to follow up with you after the webinar. All right, so first question here, Jack, is what's the minimal geochem data I can collect and still have something reasonable on which to make decisions?
Oh, I would say that if you're just starting out, perhaps you're a little low on budget, at least collect nitrate, total and dissolved iron, sulfate, methane, and, if you still have a little money left, carbon dioxide and or alkalinity. I think that's a good start for a petroleum site. For a chlorinated site, I'd probably lump onto that total organic carbon and perhaps chloride just as a starter, and you can build on it from there.
Okay, great. And we're also getting questions, requests for copies of your slides and your select, design, execute project checklist. Can we share that with the folks who would like a copy?
Yeah, we'll be able to make a PDF of the slides available, and I will provide a starter Excel checklist with sort of some seed categories and labor categories, and people can build their own from there.
Okay, great. Maybe time for one last question here. A good question that came in is, can you give an example of how an injection subcontractor did not understand the local soil, and we'll add the products being injected, and how that proved to be a problem on the site? So this person's asking, this person focuses more on when it's a problem, but maybe talk about the difference between when the subcontractor understands the local soil and the products versus when they don't, and how that's important.
Yeah, I think that's very important. Well, I've seen that in a couple different ways. First of all, I've seen contractors that perhaps were not as accustomed to working with show up on site with kind of the wrong direct push equipment, something that's not going to be robust enough for the geology that we're working under, and subsequently you waste a whole lot of time trying to push through and get fluid into the subsurface. So that's one way it can be a problem. The other one is a lack of understanding of the chemistry and the real ways to finesse the pressure and the flows. Too much is too much, and too much of a hurry usually results in bad results, a bad outcome on sites. So I think that's another way that I've seen that manifest itself, where the contractor doesn't necessarily know the chemistry and starts to go too fast, and the next thing you know, you've got product pushed into monitoring wells or daylighting at 10 different locations and really creating a problem.
Okay, great. Thank you so much, Jack. We do have some more questions, but we are unfortunately out of time, so that's going to be the end of our chat questions. To those of you in the audience, if we did not get to your question, someone will make an effort to follow up with you. If you need immediate assistance with a remediation solution from REGENESIS, please visit regenesis.com to find your local technical representative, and they will be happy to speak with you. Thanks again to our presenter, Mr. Jack Sheldon, and thanks to everyone who could join us. Have a great day.